Hello everybody and welcome to my channel. For those of you who are new, you are watching Quantum ASMR, and for those of you who aren't new, welcome back. Welcome back. So for today's video, I first of all want to say thank you so much for 100,000 subscribers. I can't believe it. Yeah, it's insane to me. And I'm so grateful for all of you who watch my channel, and my only hope is that I am doing some good for you and giving back to the community. So thank you from the bottom of my heart for subscribing, and also thank you for joining me and becoming a part of my family and watching my videos. So for today, I thought that I would recreate my very first video. So my very first video, I talked about the time-dependent Schrödinger equation, and yeah, so we're gonna do that again today. This time maybe a little bit better quality, because I can't even believe it. When I first started this channel, I was literally in my dorm room on the second bunk, on the top bunk, filming with just my iPhone, a pair of cheap headphones, and little tiny lamp. Actually, this lamp that I still have, it's in the corner. Yeah, and I'm gonna post the link in somewhere up here for that video if you want to be nostalgic and take a look at it. Maybe compare it to this video's quality. So I don't know, we'll see how it goes. But now here I am, almost 3 years later, 100,000 of you, camera, an actual camera, a ring light, a Blue Yeti microphone. I still only have one microphone. I would love to get a set of two, but we'll see. Some actual editing software, and I don't know, just a lot more experience and comfortability with you guys. I feel like I've been doing this for so long that it's just kind of become a part of like who I am and my family, and you guys. I can't even express how much you guys mean to me. And I know this is just a soft-spoken video, and we'll get into more of the ASMR stuff later in a minute. But it's just crazy to me. And who would have thought? Honestly, who would have thought? And yeah, I'm just so happy to be here and to be a part of the ASMR community. It's helped me tremendously get through some of the toughest times of my life. It's helped me get through some of my lowest mental lows. And I just hope that I'm doing the same for you guys. I do this because I love it. It has helped me, and I want to help others, and I don't know, it's just been an incredible journey. And yeah, so I think that's all I'm gonna say for now. So let's get into the actual recreating my first video part. So we're going to be talking about the time-dependent Schrödinger equation. Same concept. We're going to be writing on paper. There's going to be some paper sounds, writing sounds, tapping, and some ear-to-ear soft-spoken just explaining the concepts of the equation and how to solve it. So I hope you guys enjoy. Alright, so today we are going to be talking about the time-dependent Schrödinger equation. The time-dependent Schrödinger equation, also known as TDSE. TDSE. So I would first like to start out by actually just writing the equation, just straight up writing the equation. I feel like that's the best way to get into it. So the equation is I times h bar times the partial derivative with respect to time of psi is equal to negative h bar squared over 2m times the second partial with respect to x of psi plus v times psi. Alright, so now that we have written out our equation, we should define the terms. So I is our imaginary number, or the square root of negative 1. The square root of negative 1. H bar is Planck's constant h over 2 times pi. H over 2 times pi. We write it as h bar because h over 2 times pi it shows up a lot in quantum mechanics equations, so we just shorten it. But it's just Planck's constant over 2 pi. M is our mass. Capital V, that big V, is our potential energy. Potential energy. And last, but certainly not least, is our psi, or that capital I with the squiggly in the middle. And this one is our wave function. And our wave function has two variables. It has x, or position, and t, which is time. So our wave function depends on both position and time, which is why it's called the time-dependent Schrödinger equation. Alright, so now that these terms are defined, we can start to solve this equation. Now, in order to solve this equation, we have to consider that there are two variables that we are looking at. We are looking at x, position, and we are looking at t, time. So the way that we need to solve this is to split the two variables, or split this wave function. And we do this via separation of variables. Separation of variables. Which is basically taking apart the psi, or the wave function, and splitting it up into two different functions multiplied together. So our capital psi of x and t becomes little psi, little baby psi of x times f of t. Alright, so after splitting our wave function into two separate position and time functions, let's rewrite the equation with the separated variables, the two different functions. And we're literally just going to substitute the two separated functions in for the one giant function with the two variables. That's all we are doing. So after rewriting our equation with the separated functions, we can take a look at either side of this equation. So on the left side of the equation, we have a derivative with respect to time. This means we can pull out our position function and put it on the other side of the derivative, or behind the derivative, because it doesn't matter what that one is, because we are not taking the derivative of the position function. And on the other side, we can do the same thing with the second derivative with respect to position. We can pull out our time function and put it on the other side, or behind this second derivative. Once we've done that, the next step is to do something so that we can get the two functions on either side of the equation. Two functions on either side of the equation. And the way that we do that is simply by dividing out both sides by both functions. Both sides by both functions. So on the left side, the position function cancels out. And on the other side, the time function cancels out completely. So we're left with two functions on either side of the equation. And you might notice that over time I'm dropping the parenthesis x and parenthesis t and just having a little psi and a little f. Don't worry about that. It's just a little bit of shorthand. It doesn't change the equation. Alright, so once we've divided out both sides by psi and f, we are left with, on the left side, I h bar over f times the partial derivative with respect to t of f is equal to, on the other side, negative h bar squared over 2m times psi times the second partial with respect to x of psi plus v. And because we have two functions on either side of the equation, so one is on one side and the other is on the other side, we know, because of this, since they are equal to each other, they are equal to some constant, and we are going to label that constant E. And we're labeling it E because it actually ends up being energy. Alright, so now that we have split up our equation into separate functions and set it equal to some constant, we can look at each side individually. So we are going to look at the time function first. So let's rewrite that out. I h bar over f of df dt, and we're going to change the partial derivative into just a regular derivative, and we can do that because we're only working with one variable now, which is time, so the partial isn't necessary. I h bar over f times df over dt is equal to E. Next thing we're going to do is try to get the f itself. And we can do that by multiplying out dt and dividing out IH bar. Alright, now that we've done that, the next step is to try to get f alone. The way that we can do this is by integrating both sides. Integrating both sides. So on the left side we have the integral of 1 over f df, and on the other side we have the integral of e over IH bar dt. So on the left side, the integral of 1 over f is just the natural log of the time function. And on the other side, there's nothing integrating with t, so we're just gonna plop that t right on there and then add some constant. We don't know what the constant is. Alright, now we have f on one side, but we need to get rid of that natural log. Natural log. So to get rid of the natural log, we take e and raise that. Alright, so now that we've done that, the natural log and e cancel each other out, and we're left with f of t, or the time function. And on the other side, we have e to the negative iet over h bar plus c. Notice how I put the I on the top and made it a negative, negative, negative. That's a little sneaky thing we can do with the imaginary number. We can simplify this even further by using our exponential properties and splitting that right side up into e to the power of negative iet over h bar times e to the power of c. And because e to the power of c ends up being a constant, we're gonna relabel that to shorten it. We're gonna call it a. So our time function ends up just being f of t is equal to a times e to the power of negative I capital E t over h bar. And there you have it. There is our time function for the TDSE. Alright, last we're going to look at the position function very briefly, and I'll explain why in a minute. So again, we're going to set that position function equal to e. And notice how psi is on the bottom of the equation. So we don't want psi to be on the bottom of anything. So we are going to multiply psi out on both sides. So what we end up with is negative h bar squared over 2m times the second derivative with respect to x of psi plus v times psi is equal to e times psi. And this, my friends, is what we call the time-independent Schrödinger equation, or the TISE, the time-independent Schrödinger equation. Now, what we need to know in order to solve this equation is what is the potential energy, or what is V. If we don't know that, we can't solve it. So, our whole TISE is dependent on what V is, and V can be a number of things, and based on what V is going to give us a particular way to solve it. So, what we need to do is stop there, because the TISE is a completely different video, which I do have a video of the TISE if you I hope you enjoyed that recreation as much as I enjoyed making it. It's, like I said, it's been a journey and it's been really fun. It was really cool to go back and look at that video again and just see how far I've come. And you know, I'm not planning on stopping. I absolutely love doing this. So yeah, we'll see what this next year brings. We'll see who else joins our family, my family. And yeah, so I hope you enjoyed it, and thank you again from the bottom of my heart for being here, for viewing this. And I thank all of you who have reached out to me and said, you know, either said words of encouragement to me, or, you know, said how much of an encouragement I am to you guys. It means so much. I know I don't reply all too much just because of, you know, anxiety, but I do read everything, and you know, it makes me so happy when I see that I'm doing some good for somebody else. And yeah, so let's just keep this going. So I hope you have a good night, or a good morning, or a good day. Whatever time of day you are watching this, I hope you are doing very, very well. And I will see you all in my next video. So, again, thank you.